Hi guys, this week we're going to start introducing equivalent fractions, and a lot of you have quite a bit of experience with fractions, so some of this might be review, and we just want to strengthen our understanding and get even better at fractions. So number one here says a figure is cut into 4 equal pieces. What fraction of the figure is shaded dark? So the most important thing about fractions is that we know that the number we put on the bottom of the fraction is going to be the number of pieces. This is called the denominator. And it's going to be the number of pieces we have. So you may cut something into 4 pieces or 6 pieces or 12 pieces, but it's the total number of pieces. So we have 1, 2, 3, 4 pieces, so we're going to put 4 on the bottom. That number always tells us how many pieces we have cut the thing into. In this case, it says what fraction of the figure is shaded dark, so we know that there is 1, 2, 3 of those pieces that is shaded dark. So we will call this 3/4. Number 2 says fill in each blank with a whole number. So because the number on the bottom tells me how many pieces I have, and let me say that better. The number on the bottom tells me how many pieces my thing is cut into, and the number on the top tells me how many I have. This says I've only cut my thing into one piece. So if I have, say, pizza, I didn't cut it into any pieces. And the number on the top tells me how many of those I have. So in this case, I have 3 whole pizzas. So we know that we can have any number, any whole number over a 1, and it just becomes that number. So in this case, 3 over 1 is just 3. In this case, we're saying, okay, if I have 8 pieces and I need that to be one whole thing, then what does that mean? If I have 8 pieces, in order for me to make that one whole thing, well, I need to have had something that was cut into 8 pieces. So 8 pieces out of 8 pieces would give me one whole thing. So if the top number and the bottom number match, that will equal 1. In the next problem, we are going to make equivalent fractions. So if I start with 2/3, and I want to keep my fraction the same value, what I'm going to do is say, what did I do to the 3 to make a 12? I went times 4. If I were to do the top times 4 also, I would keep this the same. So for example, let's say I have thirds, so I've cut into 1, 2, 3 pieces, and remember the top number tells me how many of those I have. So let's say I have 2 pieces out of 3 pieces, and then each of these pieces gets made into 4 more pieces. Oops, 1, 2, 3, 4. 1, 2, 3, 4. And this one won't really matter, but we'll draw it anyway. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. It's the same size pizza, but in this case I just cut it into 3 pieces, 3 big pieces. And in this case I took the same pizza and cut it into littler pieces so that I have 12. So in order to equal the same amount, 2 out of the 3 is this amount, and then when I cut it into smaller pieces, then I need to have 8 out of 12 to have the same amount. Let's see, we could show that by coloring in all of this. So here is the the piece that I didn't eat right here, and it's 1, 2, 3, 4 pieces worth now that I've cut it up. Okay, very similar problems here. So let's talk about number 4. Here I have bigger pieces. This is the same problem backwards. I have 8 out of 12 pieces, and I want to instead talk about how many out of 3. So in this case, I am dividing by 4. 12 divided by 4 is 3, and so I need to do divided by 4 on the top, and 8 divided by 4 is 2. And so we actually know that it takes 4 slices for each one of these bigger slices. So each one of these big slices represents 4 of the little slices. That's why we can go times 4 and then get to this 12, and times 4 and get to this 8. So we can either eat ginormous slices, or we can cut it up and eat little slices, but it's going to be the same amount of a pizza. In this one, let's talk about it. I have 6 over 7, and I'm going to be cutting up my pizza. So my pizza's cut into 7 slices, and one of them is missing. I have 6 of them left, and I'm going to cut the same pizza into 28 pieces. So each of these 7 pieces gets cut into 4 more pieces until I have 28 total. And so there was a gap, that 1/7, so we'll do 6 times 4 and see that we actually have 24 of them left. There were 4 pieces difference. Remember that 4 little pieces equaled 1 big piece in that case. Whatever we do to the bottom, we have to do it to the top. All right, now we want to simplify the fraction. So when I do this, I don't always think of the best number to divide by the first time. So when I look at 10/15, I think, I think that there's a common 5. And so I want to divide the top by 5, and I want to divide the bottom by 5. And so what I get is 10 divided by 5 on the top is 2, and 15 divided by 5 on the bottom is 3. 2 and 3 are very simple numbers. You can't divide them down any further, so we've probably got that all simplified in one step. Okay, so here's a little bit bigger one, and let's do 24/40 into simple form. Now I'm going to show you that you don't always have to pick the best number first. So let me just go, okay, they're both even numbers. Even numbers mean divided by 2 or cut in half. If I divide this by 2, I get 12. And if I divide this by 2, I get 20. 12/20 is the same fraction as 24/40. They mean the same thing. This is just cut into very small pieces, and this is cut into pieces that are half, twice, let's say twice as big as these guys. So, but 12/20 is still even. And so if I have even numbers, I know I can still divide by 2. 12 divided by 2 is 6, and 20 divided by 2 is 10. All right, so I still have even numbers. 6 divided by 2 is 3, and 10 divided by 2 is 5. Now I have a fraction that has simple numbers, and I can't divide them down any further, so it'd be 3/5. Well, what if I had been able to do this from the beginning? Maybe I had seen that, sorry, that's kind of messy. What if I said, okay, to How about 4? Let's say I saw that I could cut this down by 4. 24 divided by 4 is 6. And 10 divided by 4 is, 40 divided by 10. 40 divided by 4 is 10. And then I'm to the 6/10ths, and I could say, okay, I still have even numbers. 6 divided by 2 is 3. 10 divided by 2 is 5. All right, was there still a better way I could have done that? I could have said, 24 is divisible by 6, and that gives me a 4. And no, that's not the number I was looking for. I think I was looking for 12. 24 is divisible by 12. 12 goes in there twice, and 12 goes into 40. Nope. 8. 8 goes in there 3 times, and 8 goes in there 5 times. So there's my 3/5. If you see the 8 the first time, good for you. If you don't, knock it down by 2s. You see what I mean? All right, choose all the fractions that are equivalent to each given fraction. So now we're just throwing in our understanding of positives and negatives. Remember, get something to write on here. Negative times or divided by negative is a positive. Positive times or divided by a positive is a positive. Negative times or divided by a positive is a negative, and the same way around positive times or divided by a negative is also going to be a negative. So same is positive, different is negative. Okay, so let's look at this. This fraction is positive. Positive divided by positive. Fractions are division problems. Top divided by bottom. Positive 3 divided by positive 10 is going to give me a positive fraction. The second one, negative divided by negative, is also going to give me a positive. In the third one, positive divided by negative is going to give me a negative. That's not going to work. In the fourth one, negative divided by positive is going to give me a negative. That's not going to work. And in this one, we have just this negative out to the side, which means the whole fraction is negative. That's not going to work either. So the only two that are the same are these two. In this one, we have negative divided by positive, and so the whole thing's going to be negative. So positive divided by positive is positive, not. Positive divided by negative is negative, yes. Negative divided by negative is positive, not. And then negative out to the side just means it is negative, so yes. Check. Let's just do one more of those. So A, I have positive divided by negative is negative. So I'm going to pick all the ones that are negative. This one, but not the third one because that's going to be positive, and not the fourth one because that's going to be positive. Okay, look at negative 4 over negative 7. Negative divided by negative is positive. So not the first one, negative 4 over 7 is negative. But yes, this one, 4 over 7 is positive. That's the same as negative 4 over negative 7, which is also positive. But the third one and the fourth one are both negative.